Module 4. Computer Hardware. Understanding the booting process in computers. Booting a computer is the initial sequence of operations that occurs when a computer is powered on, allowing it to start and become operational. The booting process prepares the system to run software and respond to user commands. When the power button is pressed, the computer's hardware activates, and the basic input-output system BIOS, or Unified Extensible Firmware Interface, UEFI, is engaged. This low-level program is stored in a chip on the motherboard and acts as a bridge between the computer's hardware and its operating system. BIOS or UEFI runs a power-on self-test post to check for hardware errors and ensure that all essential components, like the CPU, memory, and storage devices, function correctly. If there are no errors, the BIOS locates and loads the bootloader, a small program that loads the operating system into memory. Once the operating system is loaded, it takes control of the computer, initiating background processes and preparing the system for user interaction. The booting process can be cold, where the system starts from a completely powered-off state, or warm, when the system reboots without fully powering off, as seen during restarts. Understanding the booting process is fundamental in troubleshooting startup issues, as errors during these early stages may indicate problems with hardware, firmware, or system configurations. This critical process allows the computer to transition from a dormant state to an active, functional machine ready for use. Understanding digitized sound, a staple in modern technology, refers to converting analog sound waves into digital data that computers and other digital devices can process, store, and reproduce. This conversion is essential for delivering audio in formats compatible with today's digital platforms, such as streaming services, smartphones, and computers. Digitizing sound begins with capturing an analog sound wave, which is then broken down into thousands of small samples per second, a process known as sampling. Each sample represents a snapshot of the sound wave at a given moment. The quality of the digitized sound largely depends on the sampling rate, with higher rates capturing more detail and producing sound closer to the original analog version. Once sampled, each sound snapshot is converted into binary code, allowing it to be stored and manipulated by digital devices. These digital files, often compressed into formats like MP3 or WAV, can be easily transmitted and played back without losing much quality. The transformation of sound into a digital format has revolutionized the music, film, and gaming industries by providing precise, reliable audio reproduction across various devices. Moreover, digitized sound has enabled the development of new audio applications, such as virtual assistants, automated transcription, and sophisticated audio editing tools. As technology progresses, advancements in sound digitization continue to refine the accuracy, clarity, and accessibility of audio in the digital age, impacting both creators and consumers alike. Understanding interface design, key factors for effective interaction. Interface design creates interfaces in software or digital devices that focus on user experience and interaction. A well-designed interface allows users to interact with technology naturally, efficiently, and intuitively. The goal is to make the user's journey as smooth as possible, minimizing obstacles and enhancing usability. Several critical factors shape an effective interface design, beginning with usability. Usability emphasizes simplicity and functionality, ensuring users can navigate the interface without confusion. An intuitive design reduces learning time and enhances productivity, allowing users to complete tasks efficiently. Aesthetics also play a significant role, as the visual appeal of an interface can affect a user's perception and motivation. A clean, visually balanced design with appropriate color, typography, and spacing makes interactions pleasant and reduces cognitive load. Consistency is essential in maintaining a coherent experience across various sections of an interface. Users who encounter familiar layouts and icons are likelier to feel comfortable and confident. Responsiveness is another critical factor, particularly in the era of multiple devices and screen sizes. A responsive design ensures an interface adapts seamlessly across platforms, providing a unified experience. Accessibility also cannot be overlooked, as it ensures that the interface is usable by people with a wide range of abilities. Overall, effective interface design combines usability, aesthetics, consistency, responsiveness, and accessibility, creating an environment where users feel in control, empowered, and capable of achieving their goals. Understanding the process of rebooting a computer. Rebooting a computer is restarting its operating system, which can be done either through a soft reboot, where the system is reset without cutting power, or a hard reboot, where the computer is physically turned off and back on. Rebooting is often necessary for various reasons, such as resolving software glitches, applying updates, or clearing system memory. When a computer runs for extended periods, it accumulates temporary data and system files that can slow down performance or cause programs to malfunction. A reboot flushes out this temporary data, providing a fresh start for the operating system to function optimally. The reboot process begins when the user initiates a restart command, instructing the computer to close all open applications, save any system settings, and safely shut down the operating environment. During the restart, the computer performs a series of post-power-on self-test checks, verifying that all hardware components, such as memory and storage, function correctly. If any issues are detected, the reboot process may halt to prevent further damage. Once the system checks are complete, the operating system reloads, and the computer returns to its home screen, ready for use. Rebooting is a vital maintenance practice, especially in systems requiring reliability and speed, as it helps improve performance, resolves technical issues, and ensures the computer remains stable and secure for the user's needs. The mouse, a key innovation in computer interaction. The computer mouse's invention revolutionized how humans interact with computers, making complex systems accessible to ordinary users. Douglas Engelbart invented the mouse in 1964 and worked at the Stanford Research Institute. Engelbart was a visionary computer engineer driven to enhance human productivity and communication through computers. The initial mouse was a wooden box with 2 metal wheels, and its design was relatively simple yet effective. This device allowed users to control the movement of an on-screen pointer in a way that felt intuitive and precise. A stark departure from the cumbersome input methods available at the time, such as keyboard commands. The mouse detects the user's hand movement, converting it into signals that move the on-screen pointer. As technology evolved, so did the mouse, transitioning from mechanical to optical and eventually to wireless versions, improving accuracy and ease of use. In computer science, the mouse remains a fundamental tool in human-computer interaction, HCI. It enables point-and-click functionality central to graphical user interfaces GUIs, allowing users to select, drag, and interact with on-screen elements quickly. The mouse is an input device and a bridge that makes complex computational processes more accessible. The mouse is indispensable in design, gaming, and general computing. Engelbart's invention paved the way for user-centered computing, and its legacy lives on as an essential tool for efficient and intuitive computer interaction. Understanding the concept of a domain in networked computing. A domain in networked computing is a distinct collection of resources, including computers, servers, and devices, managed as a single unit within a more extensive network. Domains are defined by centralized control structures, typically governed by domain controllers, which manage access and coordinate resources across the network. This structure allows users within the domain to authenticate their credentials seamlessly, providing a secure, unified environment that facilitates resource sharing and collaboration. The domain controller is responsible for authentication and authorization, enabling it to assign permissions, monitor access, and enforce security policies. The computers within a domain communicate over an internal network, often utilizing protocols like DNS domain name system for resolving names to IP addresses, and LDAP, lightweight directory access protocol for managing directory information. Administrators can manage and distribute resources efficiently by grouping these computers within a domain. This arrangement is typical in corporate environments, where employees access shared files, applications, and printers while centrally managed. It allows IT teams to implement consistent security policies and software updates across all machines, promoting better security and reducing redundancy. A domain is a structured framework that leverages networked computers to enhance connectivity, security, and administrative oversight, providing a cohesive and controlled digital environment. Networked computers form a coherent unit through this domain-based organization, simplifying network management and supporting collaboration among connected users and systems. Understanding and designing effective computer icons. A computer icon is a visual representation, usually a tiny graphical image or symbol, representing an application, function, file, or tool within a computer interface. Its purpose is to provide users with an intuitive, easily recognizable cue that facilitates navigation and operation within digital environments. Icons are integral to modern computer design, as they act as visual shortcuts, allowing users to quickly understand an action or function without needing extensive textual explanations. This ease of identification is essential for enhancing usability, as it reduces the cognitive load on users by simplifying complex digital interactions. For a computer icon to be successful, it must be both visually distinct and contextually relevant. This involves simplicity in design. Overly detailed or complex icons can be confusing and difficult to discern at smaller sizes. Successful icons use a limited color palette and avoid excessive intricacies, favoring clean lines and recognizable shapes that users can identify instantly. Additionally, a sound icon aligns well with universal symbols and metaphors that users intuitively understand, such as a trash can for deleting or a disk for saving files. Consistency in style is also crucial, as it ensures that icons across different applications or devices look cohesive, supporting a smoother user experience. Finally, scalability is essential. Icons must remain clear and functional across various screen sizes and resolutions. A well-designed computer icon is simple, intuitive, and versatile, helping users seamlessly interact with technology and accomplish tasks efficiently. Assess the impact of desktops on computing. The advent of desktop computers revolutionized the field of computing, marking a significant shift from large, inaccessible mainframe computers to personal machines that offered power, flexibility, and affordability. Desktops brought computing into homes, schools, and small businesses, democratizing access to technology and laying the groundwork for the information age. Before desktops, computing was primarily restricted to institutions and industries with the resources to manage large, expensive systems. With the release of the IBM personal computer in 1981, followed by Apple's early Macintosh, desktop computers quickly became integral to daily life, fostering a cultural and technological revolution. The impact of desktops can also be seen in the evolution of program design. Early computers required programmers to work directly with machine code or assembly language, both challenging and time-intensive methods. The rise of desktops corresponded with the development of higher-level programming languages and more user-friendly operating systems, which allowed programmers to write software that could be easily shared and understood. Desktops emphasized graphical user interfaces, GUIs, and interactive software, reshaping how programs were designed and encouraging the development of applications for a broader audience. Furthermore, this shift paved the way for software suites and integrated tools that aligned with the practical needs of users.